Hello everybody, I'm K1. Welcome to my channel. When you declare a variable like int x equals 10, have you ever stopped and thought, where does that 10 actually go? Like, where is this variable living in the memory? Today we are going to break that down in a really simple way and answer the question, what actually happens when we declare a variable in C#? If stack and heap ever felt confusing before, that's totally normal. By the end of this video, they'll make sense to you. Don't worry, no scary low-level stuff, just enough to make things finally click. Jack, are you ready? Then let's go. To understand variables, we first need to talk about memory. In C#, we mostly deal with two main areas of memory. One is called stack, and the other one is called the heap. Let's start with the stack because it's the easier one. The stack is fast, simple, and it works in a last in, first out way. Every time a method runs, C# creates a little space on the stack just for that method. This is called a stack frame. All the local variables inside that method live in that stack frame. And here is the important part. Jack, listen, this is very important. When the method finishes, the stack frame disappears. No cleanup, no GC, it is just gone. So the stack is really all about scope and lifetime. Now let's look at a simple example. Here we have two fields, or two variables. When we create x, we store the value 10 on the stack. Then we say int y equals to x. This creates a brand new variable called y. The value 10 is copied. X and y don't know about each other at all. That's because int is a value type. Value types store the actual data, and when you copy them, you get a totally independent copy. In C#, we can make a custom value type using struct. Here is one example, a struct called point, which has two fields, x and y. Then we declare an instance called p1 and assign 5 and 10 to its fields, as you see in the code. Now, we create another instance, p2, which equals to p1. Let's change the p2.x to 99, as you see, but it's the same idea here. p1 and p2 are two separated values. Changing one doesn't affect the other. So as you see, the new value of p2.x is 99 and p1.x is 5. All right, now let's talk about the heap. The heap is where reference types live, things like classes. Let's take a look at this class person, which contains a field called age. We create a person called Jack in the age of 30, as you see in the code. Then we create another person called P2, which equals to Jack. Now let's change the age of the P2 to 40. When we create a person, the object itself is created on the heap. But the variable Jack doesn't store the object. It stores a reference to the object on the stack. When we do P2 equals to Jack, we are copying the reference. So now both Jack and P2 are pointing to the same object on heap. That's why changing P2.age also changes Jack.age. This is the big difference between value type and reference type. Now, here is a part that it is not clear to a lot of people. You will often hear value types go on the stack, reference types go on the heap. That's mostly true, but not always. Let's look at the previous example. There was a value type inside a class. As you know, in this example, age is a value type, but because it is inside a class, it lives on the heap, inside the object. So that's why technically it's not correct if we say value types always go on the stack. Now, what if we have a reference type inside a struct? Let's create a struct and name it to person with a string field. Now the struct itself lives on the stack, but string is a reference type. So the struct holds the reference and the actual string data lives on the heap. Finally, let's see when GC or garbage collector comes to the play. So take this method as an example. It's just creating a person object, we create the instance and we return it. It's nothing fancy. But as you know, we already discussed, when this method runs, we get a stack frame. When it ends, the stack frame is destroyed, but the object on the heap doesn't disappear right away. The question is, what's gonna happen to that object? Do you know, Jack? He doesn't. Let me tell you. As long as something still references it, it stays alive. The garbage collector runs in the background, finds objects that are no longer reachable, and cleans them up for us. So we don't have to manually free memory in C#. Of course, the process is way beyond that, but this is enough for the beginning. So, quick recap. The stack is fast and scoped. The heap is shared and managed by the GC. Value type copy the data, reference types copy the reference. Once you understand that, variables in C# make way more sense to you. Hope the content was useful for you, and don't forget to share it with your friends and colleagues. If you are a junior or mid-year developer and want to learn something related to memory and performance in a simple words, please leave a comment for me down below and I will make sure together with Jack to put it on our bucket list for future videos. Stay with me, grow with me. See you next video.